Last week, we talked about two methods for drawing random samples. The first one is the inverse transform method, also known as the inverse CDF method. In this method, you first sample from the uniform and then you apply the inverse CDF function. The other method is the acceptance rejection method, where you first sample from a good proposal distribution and then you decide whether you want to accept or reject the sample. These methods generally work when you know the distribution, either the PDF or the CDF of the random variable that you want to draw samples from. However, there can be situations where either the analytic expression, meaning the algebraic formula of the distribution of the random variable is unknown, meaning that you cannot find a good formula for the PDF or the CDF, or deriving the PDF or the CDF can be a lot of work. In that case, you might don't want to do the algebraic work yourself and you want the computer to do the work for you. A question you might have is that do we always have to know the PDF or the CDF to draw samples of the random variable? Well, the answer is not necessarily. This week, we will introduce a few special cases where you can apply special techniques to obtain random draws. This includes the transformation method, the sum of random variables, or a fancier name is the convolutions of random variables, and also how to draw random variables from the mixer distributions. At the end, we will also talk about how we can sample from some multivariate distributions. So let's take a slight peek into next week. So this week, we will wrap up random variable sampling. However, at this point, I haven't talked much about how exactly these random samples we have drawn can be useful. Next week, we will begin a new topic that is Monte Carlo integration. For those of you who do applied work, for example, me who does work in psychometrics, which is the data analysis and the model building in psychology and education, or if you work in biostats or in some natural sciences like physics and astronomy, then you might be interested in doing simulation studies. Monte Carlo integration and Monte Carlo inference are the basis of many simulation studies. By that time, I hope you will see how the random samples we have drawn can be so useful in practice.